Hello, so in this video we're going to look at chapter 6.4, the strategy for factoring polynomials. So in this section we initially take everything from 6.1 to 6.3 and we put it all together, where we're going to be given different kind of polynomials or terms, and we need to first take out the greatest common factor, then depending on how many terms that we have, so if it's 2 we can use the various patterns. If it's 3, we can use trial and error, the AC method, we can try the patterns, and if it's 4 or more, then we can try to factor by grouping. And then we can always check our work by, once we get the binomial, and then just trying to FOIL so we can get to our original equation. We want to make sure that our polynomials are in descending order. We want to make sure that we're always going to factor out the greatest common factor if we can. It'll make it easier to do the different methods. In the description below, there will be the video chapters for this video, so you can jump to the various sections that you want to see, or the various examples you want to see. There'll be linked to the textbook, the Intermediate Algebra textbook, first and second edition. There will be the shared folder where you're able to look at additional resources and examples and extra handouts if you would like, and then a survey at the bottom. So first we're given 2n squared plus 13n minus 7. And so since we can't pull out a greatest common factor first, we're able to use one of the 3 term methods. I'm going to use the AC method. So we have an a of 2, a b of 13, and a c of negative 7. If we take the a and the c, we will equal a negative 14, and it'll add up for a b of a positive 13. If we look at the various factors for 14, we have 1 and 14, and 2 and 7. And since we want them to add up to 13, we can do a negative 1 and a positive 14. Which will give you a positive 13. And so if we looked at splitting the middle term, our b, we get 2n squared plus 14n minus 7. If we look at taking out what's in common in the first one, we can pull out a 2n, and we're left with n plus 7. And since we want this n plus 7 to return, we could do a negative 1 and get an n plus 7. And our answer would be 2n minus 1 in parentheses and n plus 7 in parentheses. So next we're given 49b squared minus 36a squared. And so by looking at this, I can see that it's a difference of squares. So we know that for a, we have 49b squared, and we can write that as 7b in parentheses squared. And for b, we have 36a squared, and we can write that also as 6a squared. And so our answer would be 7b plus 6a and 7b minus 6a. So next we're given 64x squared plus 16xy plus y squared. And for this one, we can see that it is a difference of squares. So we have a and b, our a being 64x squared, and we can rewrite that as 8x in parentheses squared. And y squared would just be y in parentheses squared. And if we look at using our form, we would have a squared plus 2ab plus b squared. Plugging those values in, 8x squared plus 2 in parentheses 8x in parentheses y plus y in parentheses squared. And so our answer would be 8x plus y in parentheses squared. So next we're given 12ab minus 6a plus 10b minus 5. And so now we can see that it's 4 terms, and so we're going to use the factor by grouping. So we have the first two, we have the second two, and in the first one, we can see that we have a 6a in common. So we're left with 2b minus 1. And since we want this 2b minus 1 to return, we can see that we could pull out a positive 5, and we'll get 2b minus 1, and we'll get an answer of 6a plus 5, 2b minus 1. So next we're given 10m to the 4th minus 6,250. We can see that we can pull out a greatest common factor of 10. Pulling out a 10, we're left with m to the 4th minus 625. Now we have a difference of cubes, so we could rewrite it as m squared in parentheses squared minus 25 squared. And we could write it out as 10 in parentheses m squared plus 25 and m squared minus 25. But since we still have the difference of squares, we can still do something with the m squared minus 25. And so we'll have m in parentheses squared minus 5 in parentheses squared. And so our final answer would be 10 in parentheses m squared plus 25 and m plus 5, m minus 5. Now we could do by substitution. We could let m equal 4x minus 5, and so m squared would equal 4x minus 5 squared. So we would have m squared minus 7m plus 12. We can see that this is an x squared plus bx plus c form, and we can see that it would be a negative 4 and a negative 3. So m minus 4, m minus 3. Plugging our value back in, so we have 4x minus 5 minus 4, and 4x minus 5 minus 3. And our final answer would be 4x minus 9 and 4x minus 8.